In this video, we will discuss about spontaneous emission, stimulated emission and metastable state. Question will come like this: distinguish between spontaneous emission and stimulated emission, what is metastable state, and how amplification of laser is done by stimulated emission and radiation. For distinction between spontaneous emission and stimulated emission, mark will be awarded generally 6 marks, and what is metastable state, you will awarded 1 mark, and how amplification of laser is done by stimulated emission and radiation, it will be 1 mark. Now let us discuss about spontaneous emission and stimulated emission. Before going to discuss about spontaneous emission, you should first know what is absorption. Consider an atom which has an allowed state of energy U1. Suppose U1 is the allowed state of energy, and another allowed state of energy is E2, and E2 is at a higher state of energy than U1. From selection rule, we know the possible transition of a system from one quantum state to another. Suppose the atom is in the lower energy state U1. So this is your state U1. The atom is at lower energy state U1. If a photon of energy HF, you see, suppose you give a photon, this is your incident photon with energy HF. If a photon of energy HF, which is equal to E2 minus U1, the difference of the two energies E2 minus U1 is incident on this atom, then what will happen? The atom will absorb the energy of the photon, and transition takes place to the higher energy state E2. The photon vanishes after transition of this to the higher energy state. The incident photon that vanishes, and the photon, and we call this process as the absorption process. Due to the absorption of this photon by this atom, this is called the absorption photon process. And you have two states, E1 and E2. E2 is the higher energy state, where the you have the state of the atom. Now let us know what is spontaneous emission. What happens in spontaneous emission? As we have discussed, this is your higher energy state E2, and this is your low energy state E1. Suppose the atomic system is in its higher energy state. This is the state of initial state of the atom, which is at higher energy state. And after a time, let us say tau, the atomic system moves of its own accord to the state of the lower energy state, emitting a photon of energy HF. Suppose the atom which is at a higher energy state, they emit a photon of energy HF, and the energy of this photon is equal to the difference of the energy of the two states, that is energy of the photon HF is equal to E2 minus E1. Since this process is a spontaneous process, the emission of the photon is spontaneous, we say it a spontaneous emission. We call this process a spontaneous emission process. So there are various cases where we get spontaneous emission. The light from a glowing lamp, the glowing lamp filament is generated by spontaneous emission. The photon produced here are independent of each other. They have different directions and different phases. The different photons emitted in this spontaneous emission process have different directions and have also different phases. The light they produces has a lower degree of coherence. There is no coherence between the photons. The mean life for the spontaneous emission by excited atom is of the order of 10 to the power minus 8 seconds. Remember, the mean life of the spontaneous photon emission is 10 to the power minus 8 second, very small. However, there are some states for which the mean life tau is much longer, perhaps of the order of 10 to the power minus 3 second. We call such states as metastable state. So in case of metastable states, the lifetime of the photon is very high, that is 10 to the of the order of 10 to the power minus 3 second. So you have to remember this time. If question will come what is metastable state, you have to write that this time, order of the time for which there will be excitation of the atom is called the metastable state of that atom. So why metastable state is so important? Metastable state is very important because this state plays an important role in laser operation. So they have such long lifetimes because they can emit radiation only through processes that violate the selection rule. This is in metastable state you have the violation of the selection rule. Then let us discuss about stimulated emission. As we have discussed in case of spontaneous emission, the emission of the energy is spontaneous. But in case of stimulated emission, suppose the atomic system is in its upper state, that means in the higher energy state E2. Here you have the state of the atom. And a photon of energy HF interacts with the system. Suppose you give a photon of energy and which interacts with this atom, then the system is driven down to its lower state. That means the system which is at a higher energy state E2, that will come to the lower energy state E1. So now there are two photons. One is your incident photon, another photon which is which comes out due to this stimulation. So you have two photons where only one excited before. This one is excited before and another excited after. So these two photons, these two photons are produced by the stimulated emission. So this process is called a stimulated emission process. And you should remember that the emitted photon is in every way identical with the triggering or stimulated photon. The two photons have same energy, same direction, same phase and same state of polarization. If such thing happens, then each of the two photons can cause another stimulated emission event, giving a total of 4 photons. Suppose here you have 2 photons and these 2 photons can cause 4 stimulated photons. In this way, a chain reaction takes place which is similar to the process as we have discussed at the beginning. So, a chain reaction of similar processes could be triggered by one such event. This is the amplification of the laser by stimulated emission and radiation. So, when question will come, how amplification of laser is done by stimulated emission and radiation, you should mark that it is the stimulated emission process by incident photon. So in this video we discuss about spontaneous emission, stimulated emission, metastable state and how amplification of laser is done by stimulated emission and radiation. In the next video we will discuss about population inversion. Thank you.